Welcome, friends. We are starting our new course, which is Network Theory. Our module 1 was the overview of network elements and their familiarization. So, without wasting any time, let us straight proceed to the topic. So, in this module, we shall cover the following topics, that is idea of resistance, inductance, capacitance. They are the fundamental components of electrical engineering, and familiarization with different network components and topologies. Let us say one by one. So let us first see what is Ohm's law. This is very well known to all of you, Ohm's law. Let us say we have a conductor like this. This is a conductor. It has some physical length L and the area of cross section is A. Now, if we connect a battery or any energy source across its terminal, let us say we have two terminals. One terminal is P, another one is PQ. Now, potential at P is Vp and potential at Q, let us say it is Vq. Then whenever a source is connected across the conductor or to a conductor, a current will be flowing as shown in figure 1. So according to the Ohm's law, it states that the current flowing is directly proportional. That means current flowing is directly proportional to the potential drop across the conductor. Potential drop across the conductor. What is that? So here potential at P is Vp and potential at Q is Vq. So the potential drop or potential difference, it is basically Vp minus Vq. So this is the potential difference. So the Ohm's law states that current flowing through any conductor is directly proportional to the potential drop across the conductor. Potential drop, that means potential difference. That means Vp minus Vq. So this prevails. However, some physical conditions remains to be fixed. Number 1 is temperature. Temperature is to be fixed, and some other physical conditions like this length and this area of cross section should be fixed. Length of the conductor and area of cross section of the conductor these two things should be fixed. So if length of the conductor and area of the cross section remains fixed, then current flowing through the conductor is directly proportional to the potential drop across the conductor. So this is the Ohm's law, I proportional to Vp minus Vq. Now Vp minus Vq we can say which is proportional to V. That is nothing but it is the potential difference. It is the equation number 1. Now if you come or if you bring the constant of proportionality, which is 1 by G, so I, which is equal to 1 by G, is equal to 1 by G into V, and therefore we, from this equation, we know very well known equation to us, V is equal to Ri. V is equal to Ri, which is well known form of Ohm's law. V is equal to Ri, where what is G? G is the conductance of the material, unit should be in mho, and R is the resistance of the material or resistance of the conductor. Unit is ohm. So this V is equal to Ri. V is equal to Ri is the well-known form of Ohm's law. Now, if the length L and area of the cross section A changes, then we should have a relation of R proportional to L. That means if the length of the conductor increases, then resistance of the conductor increases, and if the cross section area of the conductor increases, resistance will decrease. So these are the two fundamental relation. So if you club them two, then you should get a well-known form is equal to R is equal to rho into L by A, where rho is called resistivity of the conductor. Its unit should be rho is called resistivity of the conductor. Unit should be ohm meter. So now what is resistance then? The resistance, it's a very vital thing, that resistance of any conductor is the property of the material that opposes the flow of current. That means if suppose this is a conductor, if this is a conductor and current is flowing, then some property of the material itself inbuilt with or intrinsic property of that material that will oppose the flow of current, so that will resist. That is why its name comes from it is resistance. So resistance is the material property of any conductor or any material which simply opposes the flow of current, that is all about, it is called resistance. Now it is very well understood that suppose if any person wants to move from some starting point and to destination point. Now that if person after traveling some distance, if he face an obstacle, then he should change his direction. So after again reaching at some other distance, again if he faces another obstacles, then again he should change his direction. After traveling some distance, if he again faces some obstacle, then it should again changes this direction. In this way, if the repetitive obstruction comes in his way, he should repetitively change his direction to reach to his destination. So that is the idea of the symbol of this resistance. That is why the resistance symbol is given in this way. It is the obstruction faced by the if the current is flowing I, then this current is obstructed by the resistance. That is why it is always it's like that, it is always changing its direction. That is why the idea behind the symbol of this resistance is chosen in this way. And now let us going back to some basic physics which is normally discussed in school standard physics. That is, if two resistance R1 and R2 are in series, then equivalent resistance should be summation of these two resistances, R1 plus R2, as mentioned in figure 2a. So R equivalent should be is equal to R1 plus R2. Similarly, if the two resistances are connected in parallel, R1 and R2, if the two resistances are connected in parallel, then the equivalent resistance would be given by this formula, R1 into R2 divided by R1 plus R2. This is the normal 11-12 standard physics. So what is the property of the series circuit? If the two resistances are connected in series, you see the current flowing through those two resistances are always same. The current remains same through R1 and R2. It does not change. It does not change. However, the potential drop across the resistance will not same. So potential drop across R1 is I1 R1 or I R1 rather, and the potential drop across R2, it should be I R2. If R1 and R2 is not equal, then potential drop across R1 and potential drop across R2 are not same. So that is why it is written potential of drop across R1 and R2, it always varies. On the other hand, if you consider the parallel circuit, since there are two paths, suppose one current is flowing I, so after reaching at this point, this current is facing two diversion. One is along this path, another is along this path. So that is why in parallel circuit, current does not remain same. Current does not remain same. So it will bifurcated into direction. One current should be I1 and one current should be I2. So I1 plus I2 here is equal to I1. So for parallel circuit, I1 plus I2 is equal to total current or supply current I. However, if you consider the potential drop, you see these 2 points are same. Let us say this node is X, this node is Y. So these 2 nodes are same. So basically whatever you will measure across this XY, that remains same. So potential drop across R1 and R2 remains same. So that is very interesting. Current does not remain same through R1 and R2 for parallel circuit. However, potential drop across R1 and R2 remains same because these two resistances are connected across two same points. Two different points. If you measure a voltmeter or if you connect a voltmeter across these two terminals, it will measure the voltage. So it happens to be the same for R1 as well as R2. So that is why potential drop across R1 and R2 remains same. Now quickly review, that is what is the resistance? It is simply resistance opposes the flow of current. The unit should be in ohm. Resistance opposes the flow of current, its unit in ohm. Now the potential drop, that is the voltage drop across resistance, is I into R. From the Ohm's law, from the Ohm's law. Moving on. Now suppose if you have a resistance R, some current is flowing I, then what will be the power dissipated in this resistance? It is given by the formula I square R. The power dissipated P, that will be equal to I square into R. Now fourth point, it is mentioned that a resistor does not absorb or deliver any reactive power. Now power, for the time being, please consider power is of two types: active power, which has unit watt, and second one is reactive power, unit VAR, volt ampere reactive. Now this reactive power, active power is denoted by a symbol P and reactive power is denoted by a symbol Q. Now this reactive power resistance does not deliver or absorb. So the reason being, let us explain this fact later on. Now please consider this statement: a resistor does not absorb or deliver any reactive power. So A resistance has no relation in terms of reactive power. It only absorbs or it only dissipated active power. Resistance is only dissipates active power. It has no role in reactive power of the electrical system. Now, next point, energy dissipated in the resistor in the form of heat is I square RT. It is quite familiar law, which is called Joule's law, I square R into T, which is dissipated in the form of heat. Sorry, this is H, not J. Now, equivalent resistance is series, as mentioned, it is summation of two resistance, or even if n number of resistance are connected in series, then equivalent resistance should be R1 plus R2 plus R3 up to Rn, all resistance, summation of all resistances. And finally, we have parallel resistance. This is the formula, R1 R2 divided by R1 plus R2. So this is the very brief recap of resistance of electrical circuit. So let us stop here. In the next section of this lecture, we shall start discussing inductor and capacitor. Thank you.